Hello. We have developed a system dynamics model for the strategic and sustainable management of groundwater resources in the Konya-Kloss Basin of Turkey. The model's geographical focus is Çumra and its agricultural sector. In this video tutorial, we're going to introduce the model interface and show how it can be used to assess various policy options under different scenarios. This interface can be reached in the link that you see in this video. First, let's take a look at the overall design of the interface. On the left-hand side, we see the cockpit under the policy scenario settings. There are multiple levers and input options that will help us test various policy scenarios on the model, and we will explore these in detail in a minute. On the right-hand side, we see that there are 4 graphs showing the behavior of groundwater table, groundwater flows, number of active wells, and average pump power over time. However, not all variables of interest are available on this page. The interface consists of 4 pages in total, all of which contain the same cockpit but display different variables of interest. To observe the behavior of different variables over time, we can navigate through the pages easily by clicking on Next Page and Previous Page button. While the focus of the first page is on water resources and infrastructure, the second page focuses on croplands, yields, and production. The third page focuses on profits, and the last page focuses on crop irrigation and average irrigation technology efficiency. Now, let's go back to the first page and discover what we can do with the cockpit. First, let's click on the Run and Live button on the bottom of the page to start the model, and then we can observe the impact of the changes we make on the cockpit. The model will not run until we click on this button. We should also note here that all the changes we make on the cockpit will be effective starting from the year 2025. There are multiple policy scenarios in the cockpit. At the top, we can change the price of crops and electricity. For example, let's increase the unit electricity price to 1 Turkish lira. Next, there is a crop rotation option. We can increase or decrease the rotation time of crops, which regulates how often a crop can be cultivated on the same piece of land. For example, while a farmer can cultivate green plants and cereal on the same field in consecutive years, sugar beet can only be cultivated once every 4 years on the same piece of land. Let's increase the green plants rotation time to 2 years. Then we see a switch for surface water. The default is off, implying that there is no surface water supply in the future. If we turn on the switch, the model requests an input for surface water supply goal. Below that, there are 3 different well regulation options. The default is open access, when anyone can open a new well whenever it's needed. Well amnesty or well peace implies that the existing wells are pardoned, but a new well can only be opened only to replace a closed well. Prohibition of new wells implies that no one can open a new well under any circumstances. Here, we can also decide on when to implement a new well regulation and how long it would be effective. In this setting, for example, prohibition of new wells would come in effect starting 2025 and would be in effect for 3 years until 2028. Next, we can select which irrigation methods to use by simply clicking on the boxes of the technologies we would like to adopt. Lastly, there are 2 different options to limit groundwater extraction. These are to limit the pump power and limit pumping. When we turn on these switches, the model asks for a maximum allowed pump power and maximum allowed pumping per well. Now, let's test an integrated policy and see its consequences on the model variables. But first, we can click on the Restore button here to reset the model to its default. Before we apply the integrated policy, let's check the groundwater table under the base conditions so that we see how the implemented policies will impact the groundwater table. As we can see here, the model foresees that the groundwater table would be 86.6 meters deep in the year 2044. Now let's implement some policies. For example, Let's increase the cereal price from 3.13 liras to 5 liras. Then we can decrease the following time to 1 year. We can add some surface water supply for the future. Let's say 200 hectometer cubes. We can select the well amnesty, which would start from 2025 and would be effective for 15 years. For irrigation technology, let's select drip and sprinkler. And maybe we can put a limit to pump power. Let's say 35 kilowatts. And now when we check the groundwater table, we see that under these policies, the model foresees that the groundwater table would be 76.6 meters deep in the year 2044, which would mean that there is a 10-meter improvement in the groundwater table compared to the baseline. Similarly, multiple other management scenario settings can be applied on the model to find which combination of policies produce the most desirable outcomes. You can also test your own scenarios on the simulator. Thank you for your interest and enjoy.